Question number 30. Which compound forms optically active compounds? That's something with a chiral carbon, a carbon with 4 different groups around it that would rotate plane polarized light in different directions because it's got 2 enantiomers, unless of course it was a racemic mixture with equal amounts of the 2 enantiomers. So we're looking for a chiral carbon on reduction. Reduction is reaction with hydrogen. So what would happen on A? There's a double bond there, so if hydrogen were to join onto here, this side of the double bond, this carbon or this carbon, then this carbon would have a methyl group, an H. This one would be CH2CH3. Oh, on this side there'd be CH2CH3. So that carbon would have a methyl group, a CH3, an H, a CH2CH3 and a CH2CH3. It's got 2 groups the same. It's not A. B. If you added hydrogen across this double bond, then this carbon could potentially be a chiral carbon, except that would be CH, CH2CH3, CH, CH2CH3, CH, and this one would gain a hydrogen as well across the double bond. That would be a CH3. Now that carbon would have 2 methyl groups, a CH3 and this one when it became a CH3. C. Well, C is potentially an idea. So when that aldehyde, when that ketone is reduced with hydrogen in the presence of something like a nickel catalyst would work, then you get that converted into an OH and an H. But that carbon there would have 2 methyl groups, so that oxygen would become, the ketone would become reduced into an OH and an H, but the 2 methyl groups would mean that one wouldn't be a chiral carbon, whereas this one would be. Butanone could be, because when that O becomes an OH and an H by reduction with something like hydrogen and a nickel catalyst, or something like sodium borohydride would be another reducing agent, that would become an OH. There'd be an H on there, it'd have a methyl group and an ethyl group. Your answer is D. How many secondary amines have the formula C4H11N? Tricky question this. The N has got to be bonded to 2 other carbons. That's what a secondary amine has. A primary amine has the N bonded to 1 carbon, the secondary amine has the N bonded to 2 carbons, and a tertiary amine has the N bonded to 3 carbons. So it's got to be bonded to 2 carbons. It's got to be in the middle of this chain. If it was at the end of the chain, it would only be bonded to 1. So this C4H11, how could it be? Well, if it was 4 in a line, the N could be between carbon number 1 and carbon number 2. It could be between carbon number 2 and number 3. That would be a possibility. If it was in between carbon number 2 and number 3, so yeah, that's the only way, isn't it? So between 1 and 2, it could be between 1 and 2. It could be between 2 and 3. 3 and 4 would be the same as between 1 and 2. However, you could have 3 in a line with the nitrogen still in the middle in between carbon number 1 and carbon number 2 and a methyl group at carbon number 2. It's B. So your answer is B. Let's have a look again then. So you've got 3 in a line, a nitrogen, and then a 4th one there, so that's in the middle. You could have 2 in a line and then nitrogen and then 2 more, so that's in the middle. If the nitrogen were here, in between these 2, it would be the same as between those 2. But you could have a branch, so C, N, H, C, and then 2 branches, 2 methyl groups, so a chain of 3 with the nitrogen in between carbons number 1 and carbon number 2, and a methyl group on carbon number 2. So your answer is B.